Codesignal, Arcade, Digit Degree. Hello Internet, my name is Joshua and I'll be solving Digit Degree from Codesignal. Let's begin. So let's define digit degree of some positive integer as a number of times to replace this number with the sum of its digits until we get one digit number. Given an integer, find its digit degree. Alright, so for example you have 5. Since it's already a one digit number, it takes 0 turns. If it's 100, you sum its digits to 1, and then you realize that it could be taken down in one turn to one single digit. If it's 91, you can see here it takes 2 turns to sum its digits to make it a single digit number. I think this is quite straightforward. I already have a plan written out to save time. Let's look at it. Oh my goodness, I did not. Oh no. Okay, so, well, awkward interlude, awkward intermission. Hello everyone. Okay, so here's the plan. Okay, so you want to create a counter, counting the number of turns it takes the n number to a single digit. Okay, and what you'll be doing is that you'll be summing its digit, and you reassign it back to n, and then with that, every time you do that, it increments this counter. Now, if n is not a single digit, you'll repeat again, but with the new n created from step 1. So with that said, let's begin. So I need a counter, and now we'll start here while n is greater than or equal to 10, because that means it's a double digit. Thank goodness it's an int. And also, if it's not greater than, whatever happens, we always want to return that n. Oh no, return the counter. Alright, so if it's greater than or equal to 10, we definitely want to increment the counter to know that it starts a new turn when we start solving it. And int sum equals 0. And now here's where we actually calculate that n value. I mean, count its n's new value. So n is greater than 0. N sum equals n modulus 10. What we do here is we only want one of the digit values. For example, here 91. 91 modulus 10 is 1. So we add it to the current sum that we're creating right here, and we divide by equals 10. So now when we do that, now we're left with the next digit is 9. 9 modulus 10 is 9. So therefore 9 plus whatever its previous sum was, it'll be there. And now when you divide by 10, it's already less than 0. We go to the next part, which is we assign n that new value created by that sum. In that case, I think this is how it works. Let's just try it with one of these. Let's just walk through it. Examples, let's try 91. Okay, 91. So 91 is greater than or equal to 10. So we increment this counter by 1. Sum is 0. Now we take it to this while loop. This condition allows it to be calculated until when you calculate it, the sum is going to be equal to 10. So now we're back here. Is 10 greater than or equal to 10? Yes, it is. We increment the counter to 2. When we calculate it all the way through here, this whole process, it's going to be equal to 1. N is less than or equal to 10, so it breaks the while condition. And we return the counter, which is 2. I think so far it's working well. Like for example, if we put 5, the counter is going to break this while condition, so it's going to return 0. That works fine. 100, the same concept. I believe this will work. Let's just try it. Sweet. Well, guys, I think you guys might like this solution. I think. All right, so it's time complexity. Oh, let's just take the worst case scenario. Let's just say that whatever digits it takes, like let's just say it's n digits. Let me think about it. And every time you calculate it, you always have to. Let me think about this. I wish there's an additional for factorial, like it'd be n, then plus n minus 1 plus n minus 2. I think it's about n squared, approximately. But its space complexity is O of 1, since you're not creating a string, you're just actually using the digits as values to actually calculate it. So I hope you guys like the solution. If you have any questions, please comment below. And like and subscribe if you like my content, and give me hard problems if you want to. I'll try to solve it. Until then, good luck. If you like and subscribe, I'll give you a digit degree of an A+, even though A is not a digit. But in my YouTube channel, it is. Wow. I was just riffing, guys. I'm sorry. You have to see it. You have to hear that. Goodbye.